Alright, this video is going to be filling in the top flap of section number 3 in your Unit 11 flipbook. We've got 4 questions here that deal with circles and the standard equation for circles. Let's go through these now. I'll try to go through these in detail for you so you are getting better at understanding them and setting them up. Question number 1 in the top left-hand corner. What is the center and radius of the circle with an equation of x minus 1 quantity squared plus y plus 3 quantity squared equals 16. So in this case, class, probably we want to do is let's remind ourselves on the top here what the format is of a standard form equation of a circle. Y equals, oh, that's not right. I'm thinking parabolas. Let's try again. X minus h squared plus y minus k squared is equal to radius squared. So with that set up, we can see that our h value is here and here. So the center of the circle is going to be at h comma k, which in this case is at positive 1, negative 3. Remember, because we have a negative in our standard form equation of a circle, that means that when we pull this out, we have to assume there was a negative here already. This is x minus positive 1, and this is y minus negative 3, and that changes to positive. So the signs of h and k both flip. Let's make a little note here, just so we have this in our flip book. Flip both signs. And then our next question is, we need to know, in this case, what is the, let's see, what is the radius? And notice, class, in our equation, this number 16 represents r squared. So that means we know that r squared is equal to 16. When we square root both sides, we will get r is equal to the square root of 16, which is 4, and we don't know the unit of measure, so we'll just write 4 units. So there is our radius. Alright, next one. What is the radius of the circle with a center at 3, 4 and a point on the circle at negative 5, negative 2? Now, this problem becomes a little more difficult than you've seen in your worksheets when there's no graph. The first thing I want to make a notation for you is the radius. If this is our center and this is a point on the circle or on the circumference, that means the radius is the distance between these 2 points. Now that's only true if one of these points is the center and the other one is a point on the circle. Now if we want to go ahead and draw a quick diagram so we can see this, let's do this real quick. I will try to quickly sketch this for you. I'll change the size of that line. Let's draw a quick graph here. And let's just say that we've got a point 3, 4 somewhere around, oops, that's not the color I want. Hang on a sec. Oh goodness, I don't know what happened there. Let's see if I can fix that. Let's try one more time with green. So I've got a, basically let's call this just a coordinate grid, and I'm going to go ahead and put a point somewhere at 3, 4. I don't know exactly where that's going to be. There's my center. There's my center of my circle, and then negative 5, 2. Oh, it's somewhere over here. Who knows exactly? That's negative 5, 2. Sorry, negative 5, negative 2. Then you guys should be able to see that the distance between these 2 points is actually the radius of our circle. And that's the point I was getting at. So we got to find the radius. We know the center already, we got to find the radius. Well, we're going to have to use the distance formula here, or we can use the distance shortcut. I'm going to go ahead and use the distance shortcut to solve this. So the way we do distance shortcut is we're going to take our first point, 3, 4, and our second point is -5, -2. And if you remember using the distance shortcut, we have to subtract these numbers. So 3 minus -5 is 3 plus 5, and that's 8. 4 minus -2 is 4 plus 2, and that's 6. The next thing in the shortcut is we're going to take that number. It doesn't matter whether it's positive or negative. Put it in parentheses. We're going to square it. We're going to put this number in parentheses, and we're going to square it. And these two numbers are going to end up being added together. So this is 64. I'll change color. This is 64 plus 36, which is 100. And the last part of the shortcut is we square root that. And the square root of 100 is 10. And that means our radius is 10 units. So if our number here is 10, now we found the two things we need to know. The center, we already know, was 3, 4. The radius equals 10. In this case, we don't know the unit of measure, so it is 10 units. Now, you could have used the distance formula to figure this out. And this actually, class, is the distance formula. Think about it. We take the two x values and we subtract one from the other. And then we square that number. We take the two y values, subtract one from the other, and we square that value. We take those two values and add them together, and then they're sitting inside of a radical, so we square root them. Up to you whether you want to use distance formula, but I'm just reminding you of how we can use the shortcut to work through that problem. Alright, so we answered the question. What is the radius of that circle? It's the distance between those 2 points. Figure out the distance either using distance formula or using the distance shortcut. Alright, question upper right hand corner. What is the equation of a circle with a center at 4, -3 and a radius of 5 feet? Okay, I like this one. This is an easy one. Because we know, class, that this must be h and this must be k, and this happens to be our radius, r. If our equation looks like this, then all we have to do is plug in the things we know. So we've got x minus 4, because we take the 4 and flip the sign because there's a negative in the equation. In fact, you know what? Let's write this way. X minus, because there's a minus in the equation, and then h is -4 squared plus y minus, actually, you know what? Why did I do -4? That's not correct. 4 is positive, so this is just x minus 4. Sorry about that. This is y minus, and we've got a -3 here, and that's squared. And then we know that our equation has radius squared. Our radius is 5, so we square it. And let's write our final equation. X minus 4 squared plus y, well, subtracting a negative is like adding a 3. And that is equal to 5 squared, which is 25. So there is the equation of this circle. Last problem. What is the center of a circle with a diameter that has endpoints at 2, 4, and -4, -2? Well, let's picture this. You guys can see what we're talking about. I'll go ahead and draw a quick coordinate grid here. Let's put an x and a y axis on here. And let's just pretend we're plotting these points. So 2, 4, let's put that somewhere around here. 2, 4. Now that's not the center of the circle. That's an endpoint of a diameter. And then we've got -4, -2. That's probably somewhere around here. -4, -2. And I want you all to see that the distance between these 2 points is not a radius now. It's a diameter. It tells us that this is a diameter. So now you're going to have to find the center of the circle. And the center is going to be the midpoint. The center is the midpoint of a diameter. So all we got to do is figure out the midpoint of this particular line segment, and that will give us the center of our circle. So let's do that now. We know that midpoint formula is x sub 1 plus x sub 2 over 2. There's our x coordinate. Add the x values and divide by 2. The y coordinate is y sub 1 plus y sub 2 over 2. Let's go ahead and label our coordinates here. Let's call this x sub 1, y sub 1, x sub 2, y sub 2. And now we'll go ahead and plug these into our equation. So x sub 1 is 2, x sub 2, this is plus x sub 2, which is negative 4 over 2. And then we've got y sub 1, which is 4 plus y sub 2 is negative 2 over 2. Next step, let's simplify. 2 minus 4 is negative 2 over 2. 4 minus 2 is 2 over 2. And our last step is going to simplify this. We've got negative 2 over 2, which is negative 1, and 2 over 2, which is 1. So our midpoint is negative 1, 1. Now, if this was actually on a grid, you could actually check that to see if it makes sense. And even our example grid, where we just kind of made up where the points were, just estimated them, you can see that negative 1, 1. It looks pretty close to being somewhere around the midpoint of that particular line segment. And that ends up being the center of the circle. That is the end of the top flap.